let's go through some examples. Okay, so let's go back to our cell phone and sleep study. All right, so we have the population mean of 7.5 hours, and then we have our sample of 10 people here that looked at their cell phones before sleep. And we want to know, is this population significantly lower than the mean population? So we can start with step 1, which is going to be our research hypothesis. And this says that cell phone use decreases time sleeping. Okay. Our null hypothesis says that cell phone use does not affect time sleeping. Okay. So now for step 2, we have to calculate our comparison distribution. We know the mean, but we don't know the variance. And we know we're going to estimate the variance from our sample size. So we need to start by getting the sum of squares, which means we need a mean for our data. Okay. And now we need to get the difference between the mean in each data point, and we square it. Okay. So we will be doing A3 minus A minus 6.3. The next thing we need to do is calculate our sum of squares. So I will be taking our data point minus the mean. We'll be squaring that. And we're going to need to do that for each data point. And then I can get the sum of each of those squared differences. And there's my sum of squares. So my sum of squares is this 22.5. But normally, if I wanted to get the variance of my data set, I would divide that by 10. But since I'm looking for the estimated variance of the population, I'm going to take that 22.5 and instead I'm going to divide it by n minus 1, which in this case is 9. So now my estimated population variance is 2.5. But I now need the estimated variance of the distribution of mean, right? Because we're working with means. So just like we learned in the last video, I take that and I divide it by my sample size of 10. So this is important. This is one point of confusion sometimes students get is they forget this step here. That's very common. But remember, for the first step, you divide by the degrees of freedom, n minus 1. And the second step, you divide by the total n, right? In this case, 10. And then lastly, we're going to have the estimated standard deviation of the distribution of means. We're going to take the square root of that variance. It's going to be 0.5. All right, so now I have what I need for step 2. So the next thing I need to do is find my t-threshold. Right? So I have a one-tail hypothesis because it's directional. It decreases. So we can go to the t-table for one tail. Right? I might have degrees of freedom of 9. And if I use an alpha of 0.05, my cutoff is 1.833. Now, keep in mind, since I'm saying it's a decrease, this is actually negative 1.833 is my threshold. Now, we can calculate the t-test. So we're going to take the mean of my sample is 6.5 minus the mean of the population is 7.5 divided by the standard deviation of the distribution of means, and I get negative 2. This is slightly above my threshold, which suggests that it's significant. Right? So I can reject the null hypothesis that cell phone use does not affect sleeping. So notice we have combined both estimating the variance of the population by using the degrees of freedom and also converting the estimated variance of the population into that variance of the distribution of means by dividing by the sample size. I calculate it using the t-test, and I use the t-table to determine the threshold. Let's see that in action one more time. So let's say there's a neighborhood watch group that thinks red cars speed more. And they find that the average speed down the road is 45 miles per hour. And they go out and they test the speed of 10 red cars. And this is the data we have here. This is our 10 red cars. And the question then becomes, are red cars speeding more? So, as with any hypothesis testing, we start with our first step. We do research hypothesis, and we say that red cars speed faster than other cars. Our null hypothesis says that red cars do not speed any different than other cars. There's no effect of red. So step 2 is to determine the population comparison distribution, mean and variance. I have the mean of 45 miles per hour, but I don't have the variance. So as we just did before, I'm going to need to calculate that by estimating off of the variance of my sample. So we start with the mean. In this case, the mean speed of red cars is 48 miles per hour. So I can now calculate the sum of squares. So we're going to take each data point minus the mean, and we're going to square that. Okay? And then we're going to do that for each one of our data points, and then we are going to get our sum of squares. And so our sum of squares in this case is 460. So to estimate the variance of the population, I'm going to take my 460 and I'm going to divide it by the degrees of freedom, which is 9. Okay. And then I'm going to get my variance of the distribution of means by taking my estimated variance of the population and dividing by the sample size of 10. And then finally we get the standard deviation of the distribution of means. We are going to take the square root of the variance. So I'm going to get something like 2.3 here. So now I need to determine my threshold. Okay? And just as before, we have degrees of freedom of 9, and it is a one-tail test because we're giving it a direction, and that's going to be 1.833 as we saw in the previous example, but it's positive this time because we're hypothesizing an increase. Now we just have to do the t-test, which we're going to take the mean of our sample minus the mean of the population divided by our calculated variance, calculated standard deviation, and we're going to get 1.3. This is not really significant. It's below the threshold, so we fail to reject the null hypothesis. All right? So this is how the t-test for so this is how we can work with the t-test for a single sample. We're going to introduce a special case now of working with two groups. So let's say you have two samples and you want to compare them. In this case, though, we're going to be working with a very specific example of this called the dependent t-test. The dependent t-test is simply the idea that our data is related to each other, usually in something like a before and after scenario. So in this case, we're looking at whether or not stress affects resting heart rate. So these researchers took the resting heart rate of 10 people right at the time of an exam, and then waited a little while and took the resting heart rate after the exam. So the question we have is there a difference in resting heart rate in the before and after group? What we're really interested in is what we call the difference score. Because there's a dependency here, what we want is we want to work with the difference score. So what we're going to do is we are going to calculate that by doing very simple before minus after. And we're going to get the difference between each subject. Now keep in mind this only works, right, because the before and after is the same individual at two different time points. So I'm getting the difference of the same person at two different time points. Once I have the difference score, I now have this single set of data, and I can do exactly the same thing that I did with the prior examples that we just finished. So we can do a research hypothesis that stress affects resting heart rate. We can do a null hypothesis that stress has no effect on resting heart rate. So now I need to determine the comparison population characteristics. Well, I haven't given us a population mean. Well, it turns out that we don't need one because we asked the question of if the null hypothesis is true, what would the mean difference score be? Right? If stress had no effect on resting heart rate, we would expect the mean difference score to be 0, right? No difference. So my population mean in the dependent t-test is just 0. But now I have to estimate the variance. We do this exactly as we have before. We start by taking the mean of our data, and then I need to get the sum of squares. So I'm going to take each data point minus the mean, which, since it's a negative minus a negative, that becomes a positive. And then we square that, right? And then I'm going to do that for each data point. Then we just need to get the sum of the values, and there I have my sum of squares. And now we estimate the variance of the population by taking my sum of squares and dividing by the degrees of freedom, which is going to be 9. And then I get the variance for the distribution of mean by taking my estimated variance that I just calculated and dividing by the sample size of 10. And then the standard deviation of the distribution of means becomes the square root of that. And now I have my calculated variance. So the variance, the standard deviation of the distribution of means becomes 0.9. All right, so now I need to get a t threshold. So things are a little bit different because in this case I have the research hypothesis is that stress affects resting heart rate. There is no direction there. So I come back to my table. In this case, it's a two-tailed test. We still have a degrees of freedom of 9. We can still use the alpha 0.05, but now my threshold is going to be 2.262. And then lastly, we set up the t-test, and that's going to be the mean of my difference score, which is negative 0.8, minus the mean of the population, which we know is 0. And then we're going to divide that by the 0.9, and we get a relatively small t-test that's well below the threshold, and so we can fail to reject the null hypothesis in this case. Okay? So the dependent t-test is the same procedure as the one sample t-test, but we have to do this difference score first. Once you get into the difference score, it's the same exact procedure. Nothing changes. You just have to remember to get this difference score first. Now you might ask, well, what happens if I have two groups that are not dependent, that are not a before and after, and I want to compare? Well, that we will cover in the next module.